to the next group of presenters. We have 4 presenters all involved in this particular project, which speaks to the collaborative nature of the projects that SSRIA is supporting. We have Madeline Height of the McMurray Métis, Genevieve Noel and McGinnis Cuchivera of Mindful Architecture, and
Right.
Trevor Butler of Arcaneers. So we'll start off with Madeline.
Hello, everyone. As Pam just mentioned, my name is Madeline Height. I work with McMurray Métis, and I'm just going to share my presentation right now. Okay. Perfect. You guys should be seeing that now. So, good morning, everyone. I'm Madeline Height. I'm McMurray Métis Audiovisual Specialist, which seems a bit odd that I'm presenting for an SSRI building, which is our Métis Cultural Center. So I've been a member with McMurray Métis for about 6 years now. It's about the same time that I moved up to Fort McMurray. Most importantly, like I said, I'm a member of McMurray Métis. I'm from Métis descent, and I'm a youth. And this cultural center, it's been a really long time coming. So McMurray Métis has been around since 1987. We're MNA Local Council 1935. You can see our first building right there. That was our olive green building. We're located up in Fort McMurray, and that was the first building that I got to know when I moved up here. It's really lovely, and it was one of the first buildings to be burnt down in the Fort McMurray wildfires. So then we moved on to our next one, which is that set of 4 gray trailers that you see there. McMurray Métis has grown a lot within the past 3 years. Our membership has gone up, our employees have gone up, and we're kind of outgrowing our 4 little trailers there. So as you can see, the last photo, that is the plan for the McMurray Métis Cultural Center. That is the mock-up building that we have right there, and that is what we are hoping for the future, for the home of the membership, where our employees are going to be working out of. So as I said, we have over 20 employees that we've outgrown those trailers. We do not fit. People are squeezing in offices. It's getting really tight here, and we have over 860 members. On those slides, you can see we've already started construction, and it's popped up a lot within, like the past 2 months. We started, I believe, 6, 7, 8 months ago. I've been here through the thick of it. I have, like I said, I've been a member for 6 years, and most importantly, I've been a summer student with them. So the different kind of activities that we're hoping to have in this beautiful cultural center is everywhere from beading networks with our elders and our youth and our members, to jigging in our multi-purpose rooms, to learning how to cook bannock and traditional meals in the kitchen, and displaying Indigenous movies. I went to school for film and TV production. I'm really excited for the theaters that are going to be in the theater that's going to be in there, the outdoor amphitheater, the park. It's going to be a place for our members and the community. This is not just a building for Métis people to go in and out of. This is for everyone. It's going to be a tourism destination for people to come in and learn about Métis culture. What we always say at McMurray Métis is that our future is the youth. So we're trying to help build a future for the next generation. I personally was put through college through McMurray Métis bursary program. I had a job to come to in the summer that focused on film and TV production. I made videos for them. And then after, to come out of college and be able to work on a project like this, I am sourcing all the TVs, the projectors, the speakers, the conferencing units that are going in this program. I am so lucky to be working on this as a youth. The future is green technology. Right now, what SSRI has been helping with is the geopiles and the earth tubes, you can see a few pictures of that, and that is what Trevor from ARC Engineers is going to touch on after McGinnis and Genevieve. So we really strongly believe that the future is green. Our youth need a building that they can go to in the future. It's going to be future-proof. We are hoping we have the geopiles in, we have earth tubes, there will be a biomass boiler, solar panels. We are going to be a carbon neutral building to make sure that our children, our grandchildren, and the generations after that will have a place to go to where future people who are interested in Métis culture and want to learn and really start working on reconciliation. Sorry, we like to say reconciliation because this ground that the cultural center was built on used to be a Métis community called Moccasin Flats, and it was taken away from us, but we have it back now, and we're going to build this beautiful cultural center to get reconciliation, to connect different communities together. So if you guys would like some more information, you can follow us on our social media page to see the Cultural Center grow. You can scan that QR code to hop on our website. We have a beautiful booklet there. And if you have any questions for me, I will be here for the Q&A, or you can contact me at madeline.height@mcmurraymétis.org. And I'll hand it over to McGinnis and Genevieve from Mindful Architecture.
Thank you, Madeline.
Thank you very much. We'll just get our slides queued up here. So I'm McGinnis Cochivera, architect and principal at Mindful Architecture.
And I'm Genevieve Noel, principal and designer at Mindful Architecture.
And so we're the architects for the McMurray Métis Cultural Center. And we were given a brief that this was to be a deeply sustainable building. And so So what does that mean? I guess it means different things to different people. And our approach was to say, what is the main problem that we're trying to solve? And that is climate change. And so since we're in the midst of a carbon crisis, we wanted to look at all aspects of the building in terms of carbon. So we, working with, we just have an absolutely spectacular team, including Reload Sustainable Design, ARC Engineers, AME Engineering, and SMP Engineering, as well as Miskamin Engineering for Structural and Structural Solutions. And working with our team, we looked at how can we sequester the maximum amount of carbon actually within the structure of the building itself. And so that really recommended an approach to use heavy timber, so glulam's and solid wood floors, but also because concrete is kind of a necessary evil when you're building. There's really not another great way to do a foundation for a large building like this that doesn't involve concrete. So we're employing the technology called Carbon Cure, which is a Canadian company, I think out of Nova Scotia, that is injecting carbon dioxide into concrete to actually mineralize to form CaCO3 or calcium carbonate.
And the emissions are actually harvested from industrial processes. So they're actually sequestering carbon that would be released into the atmosphere.
The form of the building is based on the infinity loop. And that's because the McMurray Métis, the brief called for a building and a monument. And the infinity loop is the symbol of the Métis people. And so we thought that we would instead make the building the monument so that you can see it from Google Earth, and you can know that this is Métis land just by looking down from Google Earth. The challenge, of course, then is how do we make the building rational and logical for green building? And so you can see that there's a long straight section which contains most of the program. And that is a relatively thin floor plate. It's about 13 meters, which means that light and air can come in from both sides and reach right into the middle of it. But also the long section is oriented east-west so that the long axis faces due south for maximum solar gain.
So if you can see at the entrance here on the south facade and eastern area, we have two glazed entries that are quite large, and they're meant to be sun catchers. So within these cavities where the sun will penetrate into the building, we have phase change material. So basically phase change material is a material that changes from solid to liquid back to solid, and it seeks to maintain a consistent temperature. So it harvests the heat during the day, the excess heat goes and liquefies the phase change material. And during the evening, after the sun goes down, the heat is released within the building. So we have an east-facing glazing and a south-facing glazing to catch that heat and harvest it into the building.
So crucial, of course, to any attempt at sustainability is to reduce demand. And so I won't get into all the different measures. We've really looked through the entire building with our great team and really come up with a whole bunch of different measures to reduce energy demand. Per the energy analysis done by Reload Sustainable, you can see that we're using 55% less energy than a 2017 code compliant building.
And that's excluding the renewables. So we'll be even lower with the renewables.
That's right. But of course, the one of the main strategies was to eliminate fossil fuel burning from the building itself. So there's a biomass boiler instead of a gas boiler. But of course, then the challenge is the bulk of the systems run on electricity, and much of the grid in Alberta is powered by coal-fired power plants and gas-fired power plants. So there's still a fair amount of carbon emissions to offset, which is why there's such a large photovoltaic array.
So because we're at a northern latitude there, it really makes sense to have vertical photovoltaics. So the cladding of the building is actually producing energy.
That's right. There's both rack mounted on the roof as well as vertical. So this that patterned facade that you see is actually photovoltaic panels.
So looking at the operational energy requirement of the building, we were really interested to look at how humidification is 11% of the energy demand for the ongoing performance of the building. So we were thinking of how can we lower that demand on a mechanical system in a natural way that is actually enhancing the well-being and comfort of the building. So we are looking at the natural evapotranspiration capacity of plants within the building envelope. And as we said, there's big atriums, and here you have a picture of a macro picture of a leaf surface, and you can see the pores of leaf surfaces where there's evapotranspiration. So it's active transpiration of the plants. We're integrating, here you can see it beading onto the pores. If you go to the next slide, we're integrating a lot of plantings in the atrium with an automatic irrigation system, and we can play with the lights and the irrigation to adjust the humidification of the building, which lowers the pressure on mechanical systems. This is a picture of the co-working space at the higher level of the atrium. So there's a lot of plant selection. Right now, we're calculating the humidification requirements, adjusting the plant quantities and plant specifications to seasonally adapt to the requirements of moisture in the air.
And that is the end of our presentation. And now we'll turn it over to our collaborator, Trevor Butler from Arcaneers.
Thank you very much. Hopefully everybody can see this screen. I just want to say that it's really an honor to be working with McMurray Métis and the rest of the team. We've found the whole experience educational and incredibly collaborative in seeking to develop a solution together that really meets the needs of McMurray Métis, and we're very thankful to have this small part of the team. One thing we learned was to think about the whole systems approach when we look at the building, and this is to do with starting with nature, with the air, the water, the earth, and the plants. And how all of these can work together as part of the overall systems to make the building work. When we look back in history, we see that, you know, a lot of natural systems really are used to inform how buildings operate, especially cultural buildings through the history of the Métis, and working learning from the land. That was one of the things that really sort of came out to us in the early stages of the project, how we could bring everything together and learn from the land and use that as part of our approach. So this is kind of a level 1 diagram. It's still in progress. We're seeking to work with Maddie and her team to develop an interactive board where you come into the building. You'll be able to click on different elements on a diagram, which will be slightly more refined than this. But you can say, well, how much energy does the solar generate right now? What is the earth tube performing at? How is the biomass boiler working? What's the humidity from the plants, and how do those really help? That's something working with Genevieve, we're really getting to grips with, seeing how we can get into that 11% energy load of humidification. And, you know, altogether, you'll be able to click on here and see the performance. And I think hoping with Maddie and her team that this will be an online interactive resource that people can learn from the building, especially the youth, and you know, far and wide, to really publicize this. So this was sort of our initial, some of the initial approaches. The two elements we're particularly interested in working with SSRIA and Pam and her team has been the earth tubes and the geopiles. That's something Maddie referred to earlier. So the earth tubes are the two systems out on the right-hand side and on the left-hand side, the two extremities. And these are basically bringing in outdoor air through the ground in a sealed, airtight conduit and delivering it to the ventilation systems. The advantage of that is that you can use the ground, which is a much more stable temperature than the air. And therefore, when we bring in fresh air into buildings, we don't have to heat it quite as much, because the ground has already taken off, you know, 30, 40, 50% of the load before it gets to the air handlers. The other thing with why that's really important, not just saving energy and the carbon, is in the era of the pandemic, it's been very clear that we need more fresh air in our buildings, better ventilation rates. And there's kind of a dichotomy in doing that, because we need to then provide more air, which needs to be heated, which then pushes up our carbon emissions. So the earth tube is a technology, it's well proven. We've worked with several of these projects across Canada, around the world as well, where we can bring in the fresh air and double the quantity of fresh air with no impact on energy or carbon emissions. So that's something we really think will add a lot to the building. However, we haven't done any of these as far north yet. So this is our most northerly earth tube system, and we will be monitoring it and seeing how it performs. Of course, the other advantage in the summertime is that you get free cooling from the ground, and that really helps to reduce any air conditioning loads. So we can provide lots of fresh, cool air, naturally cooled, without going through air conditioners all summer long, using the earth tube too. So that's another big advantage. The second element on here is the geopiles, which are the 6 vertical pipes that go down beneath the building. And these are integrated into the foundations. It's basically a concrete shaft, a hole drilled in the ground, filled with concrete, and pipes are installed in those, and the water is circulated through those pipes, and that comes back to provide any additional cooling that's needed. These don't go very deep. The geology in Fort Mac is quite unique, as is sort of indicative of the industries there. When you get to about 12 to 15 meters, you're generally hitting a level of sort of rock, and then just beneath that is where the tar sands are located. So there's a geology here. So these only go about 11 to 12 meters deep, these piles, which is perfect structurally. We didn't have to go too deep, but it's also good thermally, because we're not doing a formal geo-exchange system. This is more of a passive Geo-exchange system with no heat pumps required. So it's like a passive cooling, an economizer cooling system, if you like. I'm going to show you some pictures of these now, and as we progressed in site. Last summer was when the installation happened, and so first of all, I'm going to show you some pictures of the earth tubes. So the first thing to do was to build a trench, excavate a trench, and to pack the ground ready to receive the pipes. And you can see that on the right-hand side. And on the left here, this is the chamber where the tubes actually enter into the basement foundations of the building. It's a special intake shaft, and there are 5 pipes coming in. This is on the north side. There are actually 3 separate earth tube systems on the project. And you'll see this is the first one, which comes from the north. And there you can see the pipes being installed on the left, and then backfilled, packed. Working with the geotech team was really important here. They gave a lot of guidance on how we should backfill the pipes. And then the structural group there with McMurray engineers forming that chamber and just making it part of the foundations. It was a very simple exercise, and working with Paul and Andrew and their team was very, very, very helpful. And then you can see here the other array, and this has, again, 5 pipes for ventilation, but there's 2 extra pipes that come up on this one, which are for the building's biomass boilers. So the biomass boilers need to have combustion air all winter to make the combustion operate effectively, and that's where these pipes come in for that one. The geopiles are basically inserted into the rebar cages as part of the piling contract. So the piles themselves would be drilled in the ground, the rebar goes in, and then you pour concrete. But before you do that, you just insert some tubing into the cages and then lower those in with the tubes. Subcontracting team here working with Casman were Geotility, and they are a Geo-exchange subcontractor. They do a design build work, and they managed the geopile installation, working in tandem with the piling contractor. So here's the various rebar cages with the tubes in, and there's on the right, there's the pile being drilled. There's the concrete truck with the carbon cure concrete going in there. And on the left, you can see the rebar cage with the crane kind of in the middle, holding the whole cage up with the tubes in it. And that gets lowered into the hole, and there's the concrete truck waiting to pour the concrete in and surround them as part of the foundations.
Trevor, maybe just one more minute, and then we can get to some of the questions we have if that works for you.
That's good. Just wrapping up. This is a freshly made geopile on the right there. You can see the tubes coming out, and those are what connects to the building's cooling system. There is an option to provide heating through this as a Geo-exchange in the future, but for now it's just providing passive cooling. And so there are about 120 of these piles throughout the project, and we think we're going to get about 50 to 60 tons of cooling, which meets the air conditioning load. That's the end of my presentation. Thank you.